And here are the kinds of symbols that you're going to see in our circuits. This one right here is the most common one that we've been drawing. You might also see it more like that. It's an air core, there's no material inside. This one, you can see that they've added a magnetic or iron core, and why do you think they would do that? Well, if you think of a magnet, there's all sorts of magnetization domains inside of that magnetic material. You can actually see them in a microscope. If you look at it under a microscope, you can see all these tiny little domains, and the B field in each of those domains are normally randomly oriented, but if you have a B field around, they'll align themselves with that B field, and it'll make the resulting B field even stronger. Then there's, of course, adjustable inductors. A ferrite bead is what we can use to choke magnetic fields if there's electromagnetic interference and we're getting too much radiation away from the wire. We can use a ferrite bead. So a big question here is, can we store energy in the inductor? And our discussion here will be very similar to what we had for the capacitor. The power is equal to voltage times current, and that's in units of watts or joules per second. And so the electric field, the electric energy in an inductor, we'd have to take that power and integrate it with respect to time. So we'd have VI integrated with respect to time. And now we can plug in our voltage current relationship that we just derived, L di dt, and we still have I for that current. So I plug that in for the voltage, and then I can cancel this dt's, and we get L I di. So now we're going to integrate with respect to the current, and then I, if we integrate that, we get I squared, and with that 1/2 in front. So we take the derivative, we get 2 over 2, that'll go away, and we just get I. So it works, so going in the other direction. So the integrating L di, we get 1/2 I, and I have to put an L there, I squared. So this is the energy stored in an inductor. We can see that it does actually store energy according to the inductance and the current in the inductor. And as for the capacitor, it's also going to be helpful to be able to combine, if we have multiple inductors in a circuit, what the equivalent inductance is for these. And so what do you think? What would the equivalent inductance be for these 3 inductors?